Now let's look at a similar kind of problem, but with different trig functions. So these have, instead of sine and cosine, they have tangent and secant raised to some exponent. And the rules are similar, or at least the steps, I guess I should say, as what we saw in the sine and cosine, but slightly different because the derivative of tangent is not secant, it is secant squared, and the derivative of secant is secant tangent. So we got to treat these a little bit differently. We can't just find the one with the odd power and pull one out and do like we did in the sine and cosine ones. So let's look at these rules and see, or the cases, I guess we could say, and see how we can handle this. So here we're looking for either a power of secant that is even or a power of tangent that is odd. So let's see what we have in this first example. So we have tangent to the sixth, secant to the fourth. So it looks like they're both even, obviously, but we're really interested in the secant exponent being even. So what do we do in this case? So now we're going to factor out a secant squared from our integral here. So separate this out. So separate a secant squared. So tangent to the sixth is staying the same for now. And we're going to split the secant to the fourth into secant squared x, secant squared x dx. All right, so now what do we do? So once we do that, use this identity, secant squared equals 1 plus tangent squared, to express the remaining factors of the secant factors in terms of tangent. So it doesn't really matter which one you pick, I guess, but let's write one of these using the identity. And let's, I always have a hard time remembering exactly which way it goes. 1 plus tangent squared. 1 plus tangent squared x, secant squared x dx. And so now we can, what's the next thing? So now it'll tell us what to do for our u substitution. So now substitute u equals tangent x. So u equals tangent x, du equals secant squared x. Of course, you need to know these pretty well. But I think with tangent x, maybe we can talk about how we'll derive that in case you forget. So some of these you can derive pretty easily. Sine and cosine, remember easily. The rest you can pretty well derive. All right, so we'll have u to the sixth. We'll have 1 plus u squared, and then secant squared x dx is going to be du. So this gives us, we'll multiply this out, u to the sixth plus u to the eighth du. And so we get 1/7 u to the seventh plus 1/9 u to the ninth plus c. And then we'll substitute back in u is tangent x. So we have tangent to the seventh x plus 1/9 tangent to the ninth x plus c. So let's talk about these identities and derivatives before we move on. So, I mean, it's a lot to remember. So if you're using these all the time, they're fairly easy to remember. But if you don't use them, if you don't use these trig identities for, some period of time, then they're easy to forget. But you can pretty easily get them. So if we want, let's find the derivative of tangent first. So tangent x is sine over cosine. So if we want to take the derivative of this, we can just take the derivative of that. And so let's use the quotient rule. So the bottom times the derivative of the top, which would be cosine, minus the top times the derivative of the bottom. Sorry, that should be negative sine x, and then over the bottom squared. So on top, we have cosine squared x plus sine squared x, which of course is 1 over cosine squared x. So that's going to be 1 over cosine squared x, which is secant squared So that's where the derivative of tangent comes from. Now, what about this other identity that we have, secant squared x equals 1 plus tangent squared x? So maybe you have a hard time remembering, is it 1 plus secant squared or is it 1 plus tangent squared? Because that does matter. When you're looking at this one, it doesn't really matter. It's 1 minus whichever one you want. So let's see how we get this one in case you have forgotten. So cosine squared plus sine squared x equals 1. So we can divide this by cosine squared x. So divide everything by cosine squared x. So that is a 1. Sine squared over cosine squared would be tangent squared, and then 1 over cosine is secant squared. And then if you could also divide by sine squared. So let's do that. We'll just say divide by sine squared instead of cosine squared. So then you'd have cosine squared over sine squared, which would be cotangent squared. Sine squared over sine squared would be 1, and then 1 over sine squared would be cosecant. So there's our other one. So just in case you've probably seen those before when you took trig, but it may have been a while. So that's how you don't have to remember all the identities. You need to remember a few, and then you don't have to remember all the derivatives. You just need to remember a few, and then you can get most of the rest probably pretty easily. Okay, so let's look at this one, the last one. So we have tangent to the 5th times secant to the 7th. And so looking up at our cases here, we see that the tangent is odd. And so we are going to factor out a secant x tangent x, and that's from the derivative of secant. And we can do you can do the same thing, find the derivative of secant, use the quotient rule 1 over cosine quotient rule, and then you get the result. Okay, so factor out secant tangent. So let's do that. So that'll take 1 away from each of the exponents. So tangent to the 4th theta, secant to the 6th theta, and then we'll have a secant theta, tangent theta. So we're just pulling one of these from each, I guess. All right, so what's next? So now we're going to use the identity. Tangent squared equals secant squared minus 1. So it's just this one rearranged that we just found. So tangent squared. So now this is, so let's write this way first. Tangent squared theta squared. Secant to the 6th theta. Secant theta tangent theta d theta. And so let's do that substitution. And I still have to remind myself because sometimes it's hard. I don't know. Just forget. Secant squared minus 1. Just want to make sure too. That's the other thing. When you're in a test and you have all these identities, maybe just write them all down, and then you can just refer to them as you need them. So don't try to remember everything. All right, and then we have secant to the 6th theta, secant theta, tangent theta, d theta. All right, so now what? What's the next thing? So we've written all the remaining tangent factors in terms of secant. So now we're using the substitution u equals secant x. So u equals secant theta in this case. Du is secant theta, tangent theta, d theta. So we have that right here. So now it's just very simple substitution. We have u squared minus 1 squared u to the 6th and then du. So let's FOIL out u squared minus 1 squared. So u to the 6th, u to the 4th minus 2u squared plus 1 du. And then we'll distribute the u to the 6th. So u to the 10th minus 2u to the 8th plus u to the 6th. And then we integrate. Let's go up here. So we have 1/11 u to the 11th minus 2/9 u to the 9th plus 1/7 u to the 7th plus c. And then we'll substitute back. So u is secant theta. So we have secant 11th theta minus 2/9 secant 9th theta plus 1/7 secant 7th theta plus c. And there you go. All right. So really just 4 things to remember. And if you do these a few times, it gets fairly easy. And you can also, like we did with the integration by parts, if you forget the details, um, then you can try something and see if, try plugging in some of these identities, pull something out, see if it works, and go from there. Like maybe this one, you forget that when tangent is odd, you pull out the secant theta. And maybe you think you pull out a secant squared. So you end up with tangent to the 5th, secant to the 5th. And then maybe, see where it goes. And if it works, it works. And if it doesn't, then you try something else. So, I think a big part of this course and with the integration that we're going to be doing and have been doing is practicing enough to where that you don't panic if you try something and it doesn't work. You want to have some experience where you can have tools in your belt that you're confident to try, whether or not they work. And if it doesn't work, then you have something else you can try. So, all right. Anyway, if you have any questions, you can let me know.